Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video for subject Electrical Circuits 1, code BEV 10303. My name is Dr. Nur Zulaili binti Muhammad and here is my email address. So you just feel free to email me whenever you have question regarding this video. Alright? Okay, so in this video, we are going to cover the topics under chapter 3, which is circuit analysis. If you still remember, in the previous video, we had learned on the two fundamental law of circuit theory, which is Ohm's law and Kirchhoff's law, right? So, in this video, we are going to see on how to apply those two laws in order to develop the two powerful techniques for circuit analysis, which is we call as a nodal analysis and the mesh analysis, where you can see that for nodal analysis, we are going to apply the Kirchhoff current law, and for the mesh analysis, we are going to apply the Kirchhoff voltage law together with the Ohm's law. Okay? So let's move to the next slide, where we are going to see the list of contents of what are the topics that we are going to cover in this chapter. Okay, so the first of all, we are going to see what is the mesh analysis. So what does it means by mesh analysis and how to apply the mesh analysis based on the application of the Kirchhoff voltage law and Ohm's law. Okay, so the next thing we are going to do is how to perform the mesh analysis for a circuit that contain the current source, right? And then after that, once we're done with the mesh analysis, we are going to see what is the nodal analysis, and then how to perform the nodal analysis based on the application of the Kirchhoff current law and Ohm's law. Okay, and then after that, we are going to see how to apply the nodal analysis for a circuit with voltage source. And then finally, we are going to see the difference between nodal versus mesh analysis. Okay, so basically in this video, we are going to cover only subchapter 1, the first subchapter, which is mesh analysis, and then the rest of the subtopic will be covered in the next following video. Okay, so let's move to the first subchapter, which is mesh analysis. Okay, so first of all, we are going to see the definition of the mesh analysis, or we can also call it as a loop analysis. Alright, so the mesh analysis is used for analyzing circuits by using the mesh current as the circuit variable. Okay, so let's say you are given this circuit, alright, so here is your mesh current, where you have a mesh current I1, here is mesh current I2, and here is mesh current I3. So recall that a loop is a closed path with no node passed more than once. Okay, so here we call as a one loop, right? So because the node only passed once. Okay, here also can be represented by a loop. Here also can be represented by loop because the node only pass not more than once. So how about mesh? A mesh is actually a loop that does not contain any other loop within it. So here we call it as a first mesh. Here is a mesh 1, here is a mesh 2, and here is mesh 3. Okay, that's the main difference between mesh and a loop, where mesh is a loop that does not contain any other loop. Alright. So, the mesh analysis will apply KVL to find the unknown currents. So, it means that we need to apply KVL for each of the mesh, okay, in order to find what is the I1, I2, and I3. Okay, so what are the step-by-step on how to determine the mesh current? Okay, so how to determine the I1, I2, and I3. So, let's say here is your given circuit. So you need to apply I1 here, I2 here, and I3 here. So the first step, you need to assign the mesh current to the end mesh using the clockwise direction. Okay, so how many mesh current do we have is depending on the number of the mesh. Here you have one mesh, two mesh, and three mesh. So that's why you have I1, I2, and I3. Okay, so the total number of mesh current depending on the total number of mesh. And then after that, you need to assign the polarity to each of the elements in the circuit based on the mesh current direction. Okay, so we need to assign the polarity for R1, R2, R3, and so on. So for the first loop, since the current flow from this point to here, here, and here, and then you know, based on the passive element, the current will be flow from positive terminal to the negative terminal. So that's why you have here positive, and negative. And then for the second loop, okay, so the second loop, the current flow from this point to here, here, and here, complete one cycle. So that's why here you have positive, negative, positive, negative, and positive, negative. Okay, take note at the R2. The polarity based on the I1 is positive and negative, but the polarity based on I2 is positive and negative, right? So for R2, they will be having two different polarity. And then for the third cycle you have positive, negative, and here is apply positive, negative, and here positive and negative, right? And then step number 3, once you're done with assigning the polarity, you need to apply the KVL to each of the N mesh. Okay, so since you have 3 different mesh, so you need to apply KVL 3 times. And then you need to apply the Ohm's law to express the voltage in terms of the mesh current. So for example, voltage across R1 is equal to I1 R1. Okay, so voltage across R3 is equal to I2 R3. And then how about voltage across R2? Because for the voltage across R2, there will be 2 different mesh current that flow through the R2. Here you have I1 and here you have I2. So that's why voltage across R2 will be given by R2 multiplied with I1 minus I2. Okay, so we will see in details in the next following example. Okay, for the step number 4, okay, based on the step number 3, once you apply the KVL, and then you will be getting the N simultaneous equation. Okay, so here you have 3 different mesh, so you are getting 3 different simultaneous equation. So based on the 3 simultaneous equation, you need to solve the resulting N simultaneous equation in order to get the value of mesh current. Okay, so how to apply the step by step actually, so we will see in detail in the next following example. So for example 3.1, so based on the given circuit with the value of VB1 12 volt, VB2 is 6 volt, and then R1, R2, R3, R4, R5, the value is given in here. So you need to write the mesh equation for the following circuit. So how to write the mesh equation? We need to apply the mesh analysis. Okay, so the step number 1 will be, based on the circuit, you need to assign the mesh current to the 3 mesh. Okay, here you have 3 mesh, 1, 2, 3. So you have I1, I2, and I3. And then step number 2, you need to assign the polarity to each of the elements in the circuit based on the mesh current direction. So here you have positive, negative, positive, negative. So for the second mesh, you have here positive, negative, positive, negative, and positive, negative. For the third loop, you will be having positive, negative, okay, and positive, negative. And then for the step number 3, apply KVL to each of the N mesh. So in this case, you have 3 mesh. Then you need to use the Ohm's law to express the voltage in terms of the mesh current. Okay, so based on the circuit, you need to apply the KVL for the first mesh, second mesh, and the third mesh. Okay, for the mesh 1, so starting from this point, you will be having negative VB1 plus voltage across R1 plus voltage across R2. Okay, so for the voltage across R1, you're having I1 multiplied with R1. Okay, so remember you need to apply the Ohm's law to express the voltage in terms of the mesh current. Okay, so here you have I1 multiplied with R1. Okay, how about the voltage across R2? Okay, so let's say, first of all, I need to draw first. Okay, right. So for the R2, let's say you have a R2 here. Okay, and then the current flow, here you have I1. And here you have I2. Because you have 2 different current flow through the same resistor, so that's why the voltage is equal to the value of R, the value of R multiplied with, so here you have V, okay, V. So V is equal to the value of R multiplied with, from positive side to the negative side, so that's why you have I1 minus I2. Okay, so that's why here you have I1 minus I2 multiplied with R2. Here is R2, here is R2. Okay, so that is how you apply the Ohm's law for the mesh current. Okay, and then after that, you can substitute the value of VB1, R1, R2, R3, and so on. So here I have negative 12 plus 3I1 plus R2 is 8 ohm. So 8I1 minus 8I2. And then after that, we can further simplify the equation. 3 plus 8 is equal to 11I1 minus 8I2. Negative 12, I bring to this side, so I have 12. So this is considered as my first simultaneous equation. Okay, so how about mesh 2? So for mesh 2, we're starting from this point, okay, the voltage across R2, go to the voltage across R3 plus voltage across R3 plus voltage across R4 equal to 0. Then for the voltage across R2, here I have positive, negative. Okay, so in this case, I have here my resistor. So here it is R2. Okay, and then the voltage is plus, minus. Okay, so here I have I2 and here is I1. Okay, so that's why for the voltage across R2 in this based on this mesh current is equal to R2 multiplied with I2 minus I1. Okay, so you see here positive, negative. So the current flow from positive to the negative side. So I2 minus I1. Okay, R2, I2 minus I1 plus. So the voltage across R3 is equal to I2 R3. So here you have I2 R3. And then for the voltage across R4, okay, so because you have positive, negative, V, and then you have a R3, and then the current is, here is I2, and here is my I3. So that's why the voltage across R3 based on this mesh current is given by R3 multiplied with here positive, negative, right? So here I2 minus I3. So remember, you just follow based on the polarity of the voltage. Here positive, negative, so current flow from here. So I2 minus I3. So here you have R4 multiplied with I2 minus I3. Okay? And then after that, you just substitute the value of R2, R3 and R4 accordingly. So in this case, I have 8I2 minus 8I1 plus 6I2 plus R4 is 4. So 4I2 minus 4I3. Then after that, you can further simplify the equation. So here I have negative 8I1. So 8 plus 6 plus 4 is equal to 18. So I have plus 18I2 minus 4I3. So this is my second simultaneous equation. Okay. We go to the third mesh, which is mesh 3, where we have a voltage across R4 plus voltage across R5 plus VB2 is equal to 0. Okay, so for voltage across R4, you have R4 here. Okay, you have R4. Okay, so based on the for mesh 3, you have I3. So here you have I3. So voltage based on the I3 is given by positive and negative. But based on because the R4 is sharing with I3 and I2. Okay, so here the V is given by the value of R4 multiplied with, so here you have positive, negative. So current flow from positive side to the negative side. So that's why you have I3 minus I2. Minus I2. Okay? Right. So here you have R4 multiplied with I3 minus I2 plus I3 R5 plus VB2 equal to 0. And then after that, I can just substitute the value of R4, R5 and VB2 accordingly. So I have 4 multiplied with I3 minus 4I2 plus R5 is 2, so plus 2I3 plus 6 volt equal to 0. And then I can further simplify my equation. Here I have negative 4I2. So 4 plus 2 is equal to 6, so plus 6I3. And then the 6, I move to the other side, I get negative 6. So this is my third simultaneous equation. Alright, so step number 4, you need to solve the resulting 3 simultaneous equations to get the mesh currents I1, I2, I3 by using one of the following method. Okay, so you can either use the first method, which is elimination technique, and then the second method is a Cramer rule. Okay, so we are going to see for step number 4 in the next following example. Okay. Now we go to the next example, which is example 3.2. So for the following circuit, find the branch currents I1, I2, and I3 using mesh analysis. Okay, just refer to this figure. So here is the branch current. So you see this is the branch current I1, I2, and I3. And then in order to apply the mesh analysis, the first step is you need to assign the mesh currents. So here is the mesh current I1 and here is the mesh current I2. Okay, so you just need to take note that the branch current is not same as per mesh current. Okay, so to distinguish between the two types of current, usually we use the small letter of I for the mesh current, and the capital letter I is for the branch current. Okay, and then the branch current elements are algebraic sum of the mesh current. So what does it means here is you just refer to the previous figure where you have a 5 ohm connected to the 6 ohm and another resistor is 10 ohm. Okay, 5 ohm, 6 ohm and 10 ohm. So you also have a branch current that flow through the 5 ohm is equal to I1. Branch current flow through the 6 ohm is given by I2, and another branch current flow through the 10 ohm is given by I3. Okay. At the same time, you also have mesh current which is I1 and I2. Okay, so based on this figure, the relationship between the branch current and the mesh current are given by this. Okay, so how do we get this? Okay, you can just redraw back you have 5 ohm. Okay, and then you have I1 flow to this side. You have also I1 flow to this side. Okay, so in this case, I1 is same direction as per I1. So that's why I1, the capital letter I1 is equal to the small letter I1. Okay, how about I2? I2 is the current flow through the 6 ohm. So here you have 6 ohm. Okay, you have I2 here. And then you have another current, which is I2. So in this case, the flow of the capital letter I2 is equal to the flow of the small letter I2. So that's why you have capital letter I2 is equal to the small letter I2. And then next, how about the current I3, which is the current that going through the 10 ohm. Okay, so here I have 10 ohm. 10 ohm. And then I have I3. And then I also have a I1 through this side and another current I2, right? So in this case, you see the I3 will be a combination of I1 and I2. So that's why you have I3 is equal to, you see the I3 flow from the top to the bottom. I1 also flow from the top to the bottom. So that's why you can just get the current that, whatever current that flow through the same direction. So I3 will be equal to I1. Okay, I3 will be equal to I1. But because of I2 is flowed through the different direction, so that's why here you have minus I2. Okay? Alright. Okay, now we get back to the solution of example 3.2 where we need to find the branch current of I1, I2 and I3 by using the mesh analysis. So for the mesh analysis, we are going to obtain the value of mesh current I1 and I2. Then only based on this value we can find the value of the branch current. Okay, so in order to obtain the mesh current I1 and mesh current I2, we need to apply the KVL for these two mesh. Okay, so before we can apply the KVL, we need to assign the polarity for each of the element first. Okay, so the polarity for the first loop, for the first mesh will be here because you have I1 flow from this side to this side. Okay, and then for the passive element, the current flow from the positive terminal to the negative terminal. So that's why here you have positive, negative, positive, negative. Okay, for the second loop, the current flow from this point to this point. So that's why you have positive, negative, positive, negative, and positive, negative. Okay, so remember the flow will be here, here, and here. Okay. Alright, so once you assign the polarity, you can obtain the mesh current using the KVL. So we go to the first mesh, where from this point, you see the negative polarity first. So that's why here you have negative 15. Negative 15 plus the voltage across 5 ohm is equal to 5 multiplied with I1. Okay, 5 multiplied with I1. And then plus the voltage across 10 ohm. Here you have 10 ohm. And then 10 ohm, the current flow through the 10 ohm is equal to I1 minus I2. Remember I1 minus I2. Okay, so that's why 10 multiplied with I1 minus I2. And then you see another supply here plus 10 volt. Okay, and then after that, I can further simplify my equation. I have 5 plus 10 is equal to 15. So here 15I1 minus 10I2 equal to, so negative 15 plus 10 is equal to negative 5. So negative 5 bring over to this side, I got 5 here. So and then after that, we can further simplify our equation. So here 15, 10 and 5, I can divide by 5. So 15 divided by 5, I got 3I1. Negative 10 divided by 5, I got negative 2I2 equal to 5 divided by 5 is equal to 1. Okay, so this is my first simultaneous equation. Okay, and then we go to the second mesh. Second mesh, we start from this point to here and end up here. So for 6 ohm, the voltage across 6 ohm is equal to 6I2. So remember, the equation will be based on the mesh current, okay, not branch current. Okay, so here you have 6 ohm multiplied with I2 plus 4I2. Okay, because the voltage across 4 ohm is equal to 4 ohm multiplied with the mesh current I2 plus 4I2. And then here I have a negative 10 volt plus the voltage across 10 ohm is equal to 10 multiplied with I2 minus I1. Okay, remember here the polarity is positive negative, so that's why we get the same flow of direction I2. Okay, so 10 multiplied with I2 minus I1 equal to 0. And then after that, we can further simplify our equation. So here I have 10 multiplied with negative I1, so that's why I get negative 10I1. So here is 6I2 plus 4I2 plus 10I2 is equal to 20. So plus 20I2 is equal to, here negative 10, we bring to this side, I get 10. Okay, and then after that, we can further simplify our equation by dividing over 10. So here, negative 10 divided by 10, I got negative I1 plus 2I2 equal to 1. So this is my second simultaneous equation. Or you can also simplify your equation to become I1 is equal to 2I2 minus 1. Okay, so based on the simultaneous equation that you get, you see here you have two mesh, so that's why you have two different simultaneous equation. You need to solve the simultaneous equation in order to obtain the value of I1 and I2. So basically there are two methods on how to solve it, whether you are using elimination technique or you can also use a Cramer rule. Okay, so first we solve the mesh current by using the substitution method, or we can also call it as a elimination technique. Okay, so for using the substitution method, you just substitute the equation 3 into equation 1. Okay, so based on the previous slide, you have the first equation is given by 3I1 equal minus 2I2 is equal to 1. And then equation 3 is equal to I1 equal to 2I2 minus I1. And then we just substitute the value of I1 into equation number 1. Okay, so 3I1 is equal to 3I1 minus 2I2 is equal to 1. And then I1 is equal to 2I2 minus 1. So we just substitute here. And then I rearrange my equation, become 6I2 minus 3 minus 2I2 equal to 1. Okay. And then finally 6 minus by 2 is equal to 4I2. Negative 3 bring to this side. 1 plus 3 is equal to 4. And then finally I2 is equal to 1 ampere. Okay. So once you get the value of I2, you can substitute into the equation number 3 to get the value of I1. Okay. So I1 is equal to 2I2 minus 1. So in this case, I2 is 1. So you just substitute 2 multiplied with 1 minus 1 is equal to 1 ampere. Okay. So this is the value of your mesh current I1 and mesh current I2, right? And how about the second method, which is the Cramer rule? For using the Cramer rule, we need to cast the equation 1 and equation 2 in matrix form. So you just refer to the previous slide. So this is the equation 1 and equation 2. So we need to cast these two equations into the matrix form. Okay, so here you have 3, negative 2, negative 1 and 2. So you can rewrite in terms of the matrix form. Here you have 3, negative 2, negative 1 and 2. See, here is 3, here is 3, here is negative 2, here is negative 2, here is negative 1, here is negative 1 and here is 2, here is 2. Okay, so this matrix is multiplied with I1 and I2. So here I1 and I2 is equal to, so this value is 1 and 1, so that's why the matrix here is equal to 1 and 1. Okay, so once you cast the both equation in terms of the matrix form, you can solve it by using your own calculator, or you can use the Cramer rule. Okay, so how to use the Cramer rule? So first of all, we need to obtain the determinants. Okay, so how to obtain the determinants? So you just get this value 3, -2, -1 and 2. So determinants is given by 3 multiplied with 2 minus -1 multiplied with -2. So 3 multiplied with 2 is 6 minus -1 multiplied with -2 is 2. So 6 minus 2 is equal to 4. So this is the determinant. And then you need to find the delta 1 and then the delta 2. So the delta 1 is given by, the first row you will be change the value into 1 and 1. So here 1, 1. And then the second row you just copy everything here. So -2 and 2. And then the determinant is given by 1 multiplied with 2 minus 1 multiplied with -2. So here you have 1 multiplied with 2 is 2 minus 1 multiplied with -2 is -2. So 2 minus -2 is equal to 2 plus 4 is equal to 4. Sorry, 2 plus 2 is equal to 4. Then for the delta 2 is given by, so here you just copy everything 3, -1 because it's a 2. So that's why row 2 you need to change the value into 1, 1. Okay, so here you just copy. For the first row you copy, and then the second row you change the value into 1, 1. Okay, so and then after that you just find the determinant. So 3 multiplied with 1 minus -1 multiplied with 1. So 3 minus -1. So 3 minus become 3 plus 1 is equal to 4. Okay. And then finally, the value of the mesh current is given by I1 equal to delta 1 divided by delta. Okay. So in this case, delta 1 is 4 divided by 4 is equal to 1 ampere. And then for the mesh current I2 is equal to delta 2 divided by delta. So here 4 divided by 4 is equal to 1 ampere. Okay, so you can just prove that by using the both method 1, which is the elimination technique, and then the method 2, which is the Cramer rule. You are getting the same value of mesh current. Okay, and then next, finally, you can obtain the branch currents I1, I2, and I3 based on the value of the mesh current. Okay, so this is the equation that you get from the previous slide. Okay, so I1, the branch current I1 is equal to the mesh current I1, which is 1 ampere, and then for the branch current I2 will be equal to the mesh current I2 equal to 1 ampere, and then the branch current I3 will be equal to I1, the mesh current I1 minus mesh current I2 is equal to 1 minus 1 is equal to 0 ampere. Okay. Okay, now we go to the last example for this subtopic, which is example 3.3, where in this example we are going to see on how we can solve the mesh analysis for a circuit that have 3 mesh. Okay, so this is the first mesh, second mesh, and then third mesh. And then the question here, use mesh analysis to find the current I0 in the following circuit. Okay, right. So the solution for the example, okay, so the step number 1, usually you need to assign the mesh current first. So in this case, you have I1, here is your I2, and here is your I3. And then after that, you need to assign the polarity for each of the elements based on the mesh current. So the first loop will be because you have I1 flow from this direction. And then so that's why you have a voltage across the 10 ohm is equal to plus, minus, and here is plus, minus. Okay, so remember, follow the passive sign convention where the current flow from the positive sign to the negative sign for the passive element. So that's why here you have positive, negative, and positive, negative. For the second loop, you have, because the current flow from this side to here, here, and here. So this way you have positive, negative, positive, negative, and positive, negative. Right. So for the third loop, current flow from this point to this point. Right. So this way you have positive, negative, and positive, negative. Right. So once you assign your polarity for each of the elements, then the step number 3, you can perform the KVL for each of the loop, right? So you can apply KVL to the 3 mesh in turn, one by one. So you go to the mesh number 1, right? So for the mesh number 1, you apply the KVL. So from this point, you see, you go to this one, you see the negative polarity. So that's why you have negative 24. Okay. So go to this side, you see the positive sign. So that's why you have 10 multiplied with, here you have I1 minus I2. So 10 multiplied with I1 minus I2 plus, here you have the voltage across 12 ohm is equal to 12 multiplied with I1 minus I3 equal to 0. Okay, and then after that we can rearrange the equation so that we have here negative 24, bring to this side, I got positive 24, and then I can expand all this term. So I have 10 I1 minus 10 I2 plus 12 I1 minus 12 I3. And then after that we rearrange it so that we have 10 plus 12 is equal to 22 I1 minus 10 I2 minus 12 I3 equal to 24. And then after that we can divide all this equation with 2 divided by 2. So we have 11 I1 minus 5 I2 minus 6 I3 equal to 12. Okay, so this is considered our first simultaneous equation. Okay, for mesh 2, here you have, from this side, you move to here, you see the positive polarity. So there's a positive sign. So that's why you have 24 multiplied with I2, because the voltage across here is 24 I2 plus, okay, here you have 4 ohm multiplied with I2 minus I3. See the flow of the direction of the current I2 minus I3. So 4 multiplied with I2 minus I3 plus, here you have 10 ohm. 10 ohm multiply with I2 minus I1. Okay, 10 multiply I2 minus I1. Okay, and then after that we expand the equation. 24 I2 plus 4 I2 minus 4 I3 plus 10 I2 minus 10 I1 equal to 0. And then after that we can further simplify it. So here I have negative 10 I1. So negative 10 I1, 24 plus 4 plus 10 is equal to 38 I2 minus 4 I3 equal to 0. Okay, so I can further simplify it by divide the equation by 2. So here I have negative 5 I1 plus 19 I2 minus 2 I3 equal to 0. Okay, so this is considered as my second simultaneous equation. Okay, so we done for the first mesh, second mesh, and then we go to the third mesh, right? So for the third mesh, you see, you start from here, this point, then to here and finish here, right? So here you see the positive sign, so that's why you have 4 I0 plus, okay, here I have 12 ohm multiplied with I3 minus by I1, okay, so 12 multiplied I3 minus I1 plus, you see here is the 4 ohm, 4 ohm multiplied with I3 minus I2, right, equal to 0. Right, then after that, you take note, at node A, here you have I0, okay, I0 will be equal to I1 minus I2, okay, because here you have, see, you have a resistor, this is my I0, okay, I0 will be same direction as per I1 and another I2, okay, so that's why here I0 will be equal, I0 will be same direction as I1 minus I2, okay, so we substitute this thing into above equation, right? So now I have I0 is equal to I1 minus I2, so I just substitute all those things. So and then after that I can rearrange it. 4I1 minus 4I2 plus 12I3 minus 12I1 plus 4I3 minus 4I2 equal to 0. And then after that we can rearrange it so that we have, here you have 4 minus 12 is equal to negative 8I1. And then negative 4I2 become negative 8I2 plus 12 plus 4 is equal to 16I3 equal to 0. Okay. And then this is considered as our, we can we can further simplify it by divide this equation by 8. So here I have negative I1 minus I2 plus 2I3 equal to 0. Okay, so this is considered as our third simultaneous equation. Okay, so based on the all those three simultaneous equations, we can solve the equation in order to get the value of I1, I2 and I3. Okay. Okay, now in order to find the value of I1, I2 and I3, I'll be using the method 2, which is we are using the Cramer rule to solve the simultaneous equation. Okay, so basically based on the previous slide, this is the three equation that you get. So the first equation will be given by 11I1 minus 5I2 minus 6I3 equal to 12. And then the second equation is given by minus 5I1 plus 19I2 minus 2I3 equal to 0. And then the third equation is given by minus I1 minus I2 plus 2I3 equal to 0. Okay, so and then based on the equation, we cast the matrix form. Okay, right. So here you have 11, negative 5, negative 1. Here 11, negative 5, and negative 1. And then you have negative 5, 19, and negative 1. Negative 5, 19, and negative 1. And here negative 6, negative 2, 2. Negative 6, negative 2, 2. Okay, but all this matrix will be multiplied with I1, I2 and I3. So I1, I2 and I3 equal to, here the value is 12, 0 and 0. So the matrix will be 12, 0 and 0. Okay, so when you cast in terms of the matrix, then you need to find the value of the determinant. Okay, so how to obtain the determinant for the matrix 3 multiplied with 3? So what you need to do is you just copy all this value first. 11, negative 5, negative 6, negative 5, 19, negative 2, negative 1, negative 1 and 2. Okay, and then you need to repeat to continue it over again. So here 11, negative 5, negative 6, negative 5, 19, negative 2. Alright, and then you just stop. Alright, so once you get this, then only you can find the determinant. Right, so how to find the determinant? Okay, you just do the cross section. So here 1, 2 and 3 minus 1, 2 and 3. Okay, so let's do the calculation. So the value of the delta is given by 11 multiplied with 19 multiplied with 2 plus negative 5 multiplied with negative 1 multiplied with negative 6 plus negative 1 multiplied with negative 5 multiplied with negative 2 plus. Okay, and then minus, okay, minus this whole thing, this one, number 2 and number 3. So minus negative 6 multiplied with 19 multiplied with negative 1 minus negative 2 multiplied with negative 1 multiplied with 11 minus 2 multiplied with negative 5 multiplied with negative 5. Okay, and then we solve it one by one. So 11 multiplied with 19 multiplied with 2 is equal to 418. Okay, here negative 5 multiplied with negative 1 is 5. 5 multiplied with negative 6 is negative 30. So that's why here minus 30. Okay, negative 1 multiplied with negative 5 is 5. 5 multiplied with negative 2 is negative 10. So here minus 10. And then here negative 6 multiplied with 19 is negative 114. Negative 114 multiplied with negative 1 is equal to 114. So minus 114. Okay, and then here negative 2 multiplied with negative 1 is 2. 2 multiplied with 11 is 22. So minus 22. And then here 2 multiplied with negative 5 is negative 10. Negative 10 multiplied with negative 5 is 50. So minus 50. So finally the delta is equal to 192, right? So once you get the value of delta, then you need to find the value of delta 1 and delta 2 and delta 3. Okay, so next we need to find the value of delta 1. Okay, so for the second row and the third row, we just copy everything back, same with the previous slide. But for the first row, so how to do the first row? So based on this, you get 12, 0 and 0. So what you need to do is here 12, 0 and 0. And then you just copy it back. 12, 0. Okay, you copy it again. 12, 0, 0, 12, 0. Okay. And then based on the matrix, you can find the determinant value. Okay. So same thing. 12 multiplied with 19 multiplied with 2. Okay. Plus
this row will be getting 0. So 0. Okay, here also 0. So that's why I didn't put it here. So 12 multiplied with 19 multiplied with 2, you got 4, 5, 6. Okay, minus negative 6 multiplied with 19, 0. This one becomes 0. Okay, here negative 2 multiplied with negative 1 is 2. 2 multiplied with 12 is 24. Okay, so minus 24. Here the combination is become 0 because it multiplied with 0. So finally 4, 5, 6 minus 24 is equal to 4, 3, 2. So this is the value of delta 1. Okay. So how about delta 2? About delta 2, just copy everything from the previous slide here. The first row and the second row. But for the middle row, which is because here is delta 2, so the second row will be, you copy 12, 0, 0, 12, 0. Okay. Right, and then after that we can find the value of the determinant. So this combination will be getting 0. 11 multiplied with 0, 0. So negative 5 multiplied with 0 also 0. So here negative 1 multiplied with 12 multiplied with negative 2. So I got equal to 24. Alright, and then minus this thing. So minus negative 6 multiplied with 0 multiplied with negative 1, 0. So here also 0. So minus 2 multiplied with 12, 24. 24 multiplied with negative 5 is equal to negative 120. So minus become plus. So 24 plus 120 is equal to 144. Okay, so this is the value of delta 2. Next, we need to find the value of delta 3. So the matrix will be given by this matrix. So the first row and then the second row, you just copy everything. But for the third row, you just put the value of the output, which is 12, 0, 0 and 12, 0. Just copy it back. Alright, then based on this, we need to find the determinant value. So 11 multiplied with 19 multiplied with 0 is 0. So here negative 5 multiplied with negative 1 multiplied with 12. So I'm getting 5 multiplied with 12 is 60. Right, minus 12 multiplied with 19 multiplied with negative 1. So which is 228. Okay, sorry, negative 228. Okay, so this is minus 0 and minus 0. So finally 60 minus negative 228 becomes 60 plus 228 equal to 288. Okay, so once you get the value of delta 1, delta 2, delta 3, and then you can just find the value of I1, I2, and I3. So I1 will be equal to delta 1 divided by delta. So delta 1 is 432 divided by 192 is equal to 2.25 ampere. Okay, so for I2 is delta 2 divided by delta, which is 144 divided by 192 equal to 0.75 ampere. And then finally the I3 is equal to delta 3. Here delta 3 divided by delta 288 divided by 192 is equal to 1.5 ampere. Okay. And then based on the value of mesh current, then only we can find the branch current of I0. Okay, so I0 will be I1 minus I2. So I1 is 2.25 minus 1.5. Sorry, minus 1.75. So finally, I0 is equal to 1.5 ampere. Okay, so that's all for now. Thank you for watching my video. I'll see you in my next video. Okay, bye.